welcome Dick and Bill. For anybody who doesn't know, my name is Kurt Graining, and I am an executive VP with Securis. We're an industry leader in drive shredding and IT asset disposal. And today we're here to talk about two important issues: sustainability and national security. For those of you who may or may not know Bill and Dick, I'll just read a quick bio, and if I miss anything, maybe the two of you can help me a little bit. But Dick Schaefer actually is a former executive with the National Security Agency, NSA, and he spent almost 50 years in information security, cybersecurity, and intelligence. And he's still pretty active these days, doing things like working for Riverbank Associates, working for Paladin, in terms of investing in some up-and-coming technologies, and he's also a principal in Endeavor Technology. Did I miss anything, Dick, you want me to point out?
No, that's it. I'm an old guy who's been around, seen a lot.
Awesome, that's great. And Bill, it's great to have you on as well. I'm excited to introduce people to Rare Element Solutions, which is a company that recently has been created to solve supply chain issues for the U.S. Department of Defense. And I know you've been around also for a while, working for people like Seagate, Sun, DAC, Storage Tech, Quantum. If there's an expert out there in the data storage industry, I think your resume, kind of screams that. So I'm really excited to have you on and introduce people to what Rare Element is doing.
Thanks, Kurt.
Awesome. So maybe Dick, if I could start with you, to help our audience, can you explain to people how supply chain became a national security issue, or became an issue that maybe more people are now aware of today?
Yeah, I think, Kurt, it's more the latter. Supply chain has always been a national security issue, whether that is in the aerospace and defense, whether that's in intelligence, whether anytime the U.S. government has built something to execute or conduct a mission, the things that go into the technology that supports those missions has always been critical. We haven't always thought about it in the context of supply chain. We would design things, we would order material, we would build things, we would test them, we would deploy them, and eventually we would they'd reach end of life, and they'd probably end up in a warehouse somewhere. Or I started out life in the Marine Corps. We were the folks that got everything after the other services were done using them. So we learned how to do a lot with very little. But over the last 10 years, the concept of protecting supply chain, understanding supply chain, protecting the supply chain has become more and more important. And then I think during the COVID era, when all of a sudden the containers sat on ships in harbors on the West Coast or on the East Coast, and components couldn't be brought ashore because of the shortage of personnel or the inability to move the material out of the off the docks and so forth, people became more aware of just what it meant when you couldn't order material, get material, build things, deliver things, and so forth. And there's always been an issue with, at end of life, how do you ultimately take something that has been a critical mission component? I'll say, all my years at NSA, we worried about national security systems. So those systems that process classified information or were part of weapon systems. And you worry, how do you destroy devices that are part of that ecosystem, such that if an adversary was to obtain those devices, they couldn't extract anything from them that was useful. And NSA was responsible for setting the standards for how that was done. The discipline to do that, I'm not always sure was at the highest level that it needed to be, because I think, IGs and others would find warehouses where there was equipment stored that probably should have been destroyed years ago, or things were done just out of expediency, and weren't given or the people who were actually doing it weren't even aware of the requirements for how things should be processed. But I think we're in a time now, in a phase when supply chain's important, and it's important to think about supply chain from whether it's mining ore that creates the aluminum, titanium, other metals from which gearboxes or other kinds of devices that go into aerospace and defense components, or whether it's the sand that forms the silicon devices from which microelectronic devices are produced, and then ultimately at the end, how those things are recovered. I think it's a much bigger issue today, but it's not new. It's the attention we're bringing to it, the capabilities that we can bring to that environment, and then ultimately, how do we ensure that we're maximizing the value chain that part of this whole process as well. So probably more than you wanted on just the national security aspects of it, but it is it's an extraordinarily complex topic, not well understood by a lot of people who are outside of the immediate area impacted by supply chains.
Perfect. Yeah, thanks for that. Bill, when I talk to a lot of people about sustainability, they're thinking about Earth Day, recycling cans, can I buy an electric car? But maybe an area that they might be less familiar with is electronics. How does electronics play a role in sustainability?
Well, I'll start and then maybe kick it over to Bill. We, as I pointed out earlier, NSA is responsible for the destruction piece. Mm-hmm. So there are materials that we're able to mine in the U.S. Or mine in partner countries that become the feedstock, if you will, for the microelectronic devices. We used to produce a lot of them here. Actually, NSA used to have its own foundry. We used to build our own chips. NSA doesn't do that anymore. There are a few microelectronic fabrication facilities here in the U.S. Maybe there will be more in the future with the current thrust of the current administration. But a lot of that comes from offshore, and so the devices are fabricated, they're manufactured, they're delivered, and then they're put into systems here. And it used to be that when we destroyed something like a solid state drive or a hard drive or something like that, we'd crush it up and then take it to a landfill. It became part of the terrain. And that was done because we didn't have the ability to recover the devices, even the precious metals. In a lot of cases, you look at a printed wiring board today, it's got there's silver there, there's gold there, and in a lot of cases we just crush it up and it goes to landfill. And you say, now, are there ways in which we can actually at a reasonable price point recover some of that material so that we can feed it back into the front end of that big supply chain loop?
Yeah, Maybe we'll talk about the economics at the end. Bill, any thoughts or things you want to add to that?
No, and I agree with Dick in his opening remarks that there was a lot of focus coming to this prior to COVID and the pandemic, and where a lot of our materials for what the U.S. government uses and the banks and everyone else were coming from China. But to Dick's point, the pandemic really put a microscope on so much when we could no longer get it into the country. We really became very evident where the products or the sub-assemblies or materials were coming from. And as a result, created, rightfully so, an alarm around where are these things coming from and how much at risk was the U.S. because it didn't really understand all the dynamics of the supply chain. And now it has really become very much a focus, which I think is great. Sorry it had to be a pandemic that brought us to this point, but for a good outcome as a result.
Great. Well, to the good outcomes, what are some of the things, strategies, or programs that the U.S. government is employing to solve some of these issues? I don't know, Dick, you want to take that one?
Well, yeah, let me start, and again, I'll let Bill chime in here as well. I think it's okay. The U.S. government now recognizes that there's an issue. The problem is, and like we do with so many big challenges in the federal government, there's a lot of people who are involved. And whenever there's a lot of people involved, it usually ends up where no one's in charge. So if you think of supply chain security today, everybody's got a little piece of it. Everybody in the federal government. So you've got the Department of Defense. Yeah, they've got a big role. You've got Department of Homeland Security. They've got a role. Department of Commerce has a role. And in defense, if you look down amongst all the defense departments and agencies, everybody's got a little role. And there really isn't. There are policies. There are regulations. There are best practices, but there really isn't a U.S. government champion who is what I would call the great advocate for both the materials and the processes, and who can set priorities. So if we need, I'll do something simple, like if we need aluminum for manufacturing of aerospace and defense systems, that can be air breathers, it can be satellites, it can be remotely piloted vehicles, unmanned aerial systems, drones. It can be a whole series of things. So there's probably 20 different kinds of aluminum. Now, if you go to the mines and you say, okay, I think it's bauxite that you create aluminum from. Okay, here's a mine. We mine the ore, we process it somewhere, we create the alloys of aluminum by adding stuff to them, and then they go off to be satellite components or airframe components or whatever they do. Oh, and some of this stuff has to be of a form where it can be machined, where it can be, and so the supply chain for that, from the mining all the way through to the delivery of the components, is there's probably 10 or 15 departments and agencies that are involved in that whole process. The Health and Human Services, from an OSHA standpoint, what can people do? What can't they do? So, but there's nobody who's sort of sitting at the top saying aluminum is a critical component to aerospace and defense, and we need to ensure that we've got input into that supply chain, into that the beginnings of the manufacturing, the creation of the material, and then in the end, how do we recycle that stuff? Okay, we've got an F-15 that's no longer serviceable. We were flying A4s when I was in Vietnam, and when they got shot up, we took them out in South China Sea, and a big CH-53 would carry them out there and dump them in the ocean or dump them in the sea, and they're probably disintegrated by now. That wasn't very effective, but it's kind of a government mindset if there's nobody saying, here's the priorities, here's the processes, here's what we need to do in order to be able to create, here's what we need to be able to do to at end of life to recover, and here's how all the agencies will play together in order to make that all happen. We just don't have that today.
Yeah, great background. So you gave us some examples of, planes and weapon systems and aluminum. Bill, you're kind of our resident expert here on the interview on data storage. Tell me about hard drives. What do hard drives have inside of them that make them so valuable to the DoD?
So, to Dick's point, a lot of the connectors use precious metals.
Mm-hmm.
In fact, the platters have been different materials over time, whether they were aluminum or glass, and all of that is recyclable. Both of those particular things are very recyclable. But at the end of the day, data storage is about zeros and ones. And historically, how we've created the data on any storage device, the zeros and ones has to do with magnetism and using magnets. And as we get more and more sophisticated, as we shrink these things down, you need more and more sophisticated magnets, which has led us to building the magnets out of rare earth metals. And because everything Dick said earlier about the difficulty in mining those ores, the difficulty in finding them, the difficulty in processing them, they have become more and more valuable. And that's why responsible retirement and reclamation becomes such an imperative, because those materials are so hard to get.
Awesome. Yeah, thanks for that. Dick, you kind of answered this question that, telling us there's at least 15 different agencies in the federal government helping with this problem. I have some knowledge that DOE is also helping with some research grants in this area. Is there anything that stands out there in terms of work that's exciting?
I'm probably not as
yeah, and that's an area outside of your experience. I know that they're one of the 15.
I would just say, from a DOE perspective, I mean, the U.S. government has long used the DOE labs as, I'll say, think tanks and basic research components to explore ways of doing things. Kind of a simple term, ways of doing things. Anytime we had a hard problem, whether it was nuclear fusion or fission, or whether it is possibly recovery of material, we've used the national labs as think tanks within the government, classified environments in many cases, to explore solutions to big hard problems. And so the ability to create those solutions is interesting, but it's not very helpful if you can't get them out and then make them commercially viable. And tech transfer is always hard, but if you can find ways to move the science, move the process from the laboratory to a commercial entity that can create a value proposition for executing the process, then what we've got is a winner. We've got government investment in a national lab creating a solution to a problem that can then be productized and turned into a money-making commercial entity, which then satisfies the need of a large group of people, not just a couple of scientists inside a lab.
Well, that's a good point, Dick. So speaking of winners and commercial viability, Bill, what made you think that you needed to start a company to help solve this problem?
It's funny, and it perfectly goes off what you just talked about. While still working at Seagate Federal, they were looking for a more responsible way they're very much into doing the responsible things for the earth. And I got tasked by my manager to go figure out what was going on in responsible retirement and reclamation around hard drives. It led me to do a year-long research to look at various technologies. What I found was multiple DOE labs had developed differing technologies to get the magnets out of hard drives and to effectively get the materials back to a certain state. And we evaluated all those, and the DOE, and I've been on the Hill a number of times while I was doing this project. They started doing a lot of this research in 2010, well before it was quite the crisis that it is now. And they have now created these various technologies. They have made them licensable to commercial firms. And so we stood up a firm purpose-built to go take some of these DOE technologies and prove them out commercially, but in particular with a focus on how to help DoD and the intelligence community responsibly retire the equipment from those sites in a certain manner and to get the materials into the strategic reserve that has been set up for the rare earth elements. And so a perfect cycle to take, both from terms of chain of custody. These are devices owned by the government, and giving back whatever products are produced back to the government for their own use.
I love it. Solving some of both the economic problems, the data security problems, as well as sustainability. Is there anything more that you want to say about the methods that you plan to use, or more detail? You talked about how you're going to recover and then store the rare earth. Anything more you want to say about either of those, Bill?
Yeah, I would say that we're not fixated on just doing this with hard drives. DOE has done a great job of researching reclaiming rare earth elements from all manners of magnets in everything, whether it's in EVs or it's in windmills or whatever. The windmills are a huge issue on how we retire those and what we do with them. So we're looking at all manners of technology that have been developed by the U.S. government labs and how to build a commercial capability that allows us to do a full life cycle of anything that has been bought and paid for by the government, whether it's the research or it's the actual devices.
Perfect. Thank you for that answer, Bill. Dick, I understand you worked at the NSA. You were explaining a little bit of this to me earlier. You mentioned the Center for the Center for Storage Device Sanitization. Try to get it right. I think now it is under what is called the Cyber Directorate. Can you talk about any of the standards that NSA has developed, or maybe working in concert with some of the NIST standards that protect the DoD and also the DIB or the Defense Industrial Base when it comes to cybersecurity risk associated with end-of-life electronics?
Yeah, so it's again, I'm going to use this term life cycle. If there is a national security system, so a system that processes classified information, then NSA, as in its national manager role, sets the standards for destruction. So they set the standard for, we'll use Bill's example of a hard drive. They'll tell you, you've got to you've got to try to remove all of the information that's on the drive. So you want to degauss it. You want to make sure that you've done as much as you can do. We talk about writing ones and zeros to the platters. That's a method. But ultimately, you're going to grind that thing up. You're going to turn it into, essentially a handful of metallic particles. And what NSA will say is, this is how small those particles have to be. And so they will set the specification for the machine. Think of it as a grinder. So you're gonna throw it into a grinder. It's gonna a bunch of particles are gonna come out the bottom, and they're gonna be of a size that NSA will say, we have a high degree of assurance that no one could recover information from that device when processed through this cycle, this writing of ones and zeros or degaussing, of grinding, and ultimately you're left with something. And NSA will do that for not just hard drives, but they'll do it for microelectronic devices, solid state drives, and so forth. The challenge is, so people in the national security community are aware of those specifications because they're part of that community, but they also form a corpus of best practices that private sector that has sensitive information on their devices should also be following. So it's in this life cycle, and this happens quite often. It'll be the Department of Defense or the intelligence community will create a process because of classified information, data objects that are very sensitive. And ultimately, as the private sector looks at that and says, it's not classified in a national security sense, but it's damn important to me. It is the lifeblood of my company. And therefore, I'm going to treat that information, those data objects, in the same way that the US government might treat their classified information. I'm going to be assured that in the end, nobody can recover that information and steal my intellectual property or whatever. So gradually things leak from the defense and intelligence space into the private sector, become common usage, and the nation is better off from it. We don't do enough, and this is where I get back to my nobody being in charge. Nobody's really pulling all the pieces together and saying, yes, we have national security information, but we also have very sensitive industrial information. We have very sensitive health care information. And we ought to ensure that we're treating all of these categories of data appropriately, and ultimately scale means everything. If Bill's company is only processing 1,000 hard drives a week, that's one price point. But if somebody said, well, Bill, I need you to process 100,000 a week, he's going to get a whole lot more efficient in the way that he does that. And then the output, which is sort of these rare earth elements that are ultimately recovered from these processes, become more plentiful, they become less expensive. And oh, by the way, there's more of them that can go back into, I don't care whether they come out of the private sector or whether they come out of the national security sector. If I can feed them back into that national need for rare earth elements, I'm minimizing then the amount of material that we've got to import from other countries. And so there's this term life cycle takes on a much more significant meaning, because it's now Bill and rare earth elements is sort of sitting almost at the end of that life cycle. Something has to be done probably to process that material to get it back into the national stockpile, but that's becomes a very critical part of the supply chain, not just for government, but for private sector as well. And I use private sector to mean everything that's not U.S. government.
Yeah, thank you for that, Dick. We do have some educated customers that come to us here at Securis, and they will ask us about the National Industrial Security Program Operating Manual. Many times they will quote, 32 CFR Part 117. Some of my older customers will still ask about DoD 5220, which is pretty outdated. But you talk about what's spilling into the private sector. Traditionally, what I hear from civilian agencies is that they are following NIST publication 800-88. But I'm also hearing that from banks and hospitals in the private sector. So the good news is the work that the taxpayer is funding around cybersecurity, that is flowing out into organizations that are protecting citizen data, our financial systems, energy sector, et cetera. So that's there is some good news there.
Well, let me just give you one additional piece of good news, or
okay.
what should be good news.
Okay.
NSA creates specifications, NIST creates specifications, and I'll say people inside the system understand those things, but you don't understand the specifications for the tires that are on your car.
Right.
You just go to Goodyear and
Yeah.
you buy a set of tires, or you go to Firestone or whoever you go to, you go there and you buy a set of tires for your car. That's the end point. That's where we've got to get this to, where people don't need to know the specifications. They don't need to know sort of is the grinding machine, does it meet this spec? What they need to know is that for the national good, they're taking their outdated, no longer usable microelectronic devices, and they're putting them into a process that ultimately ends up doing good for the nation. And again, I go back to I'm looking for this grand poobah, who's going to be the sage on the mountain, but we don't talk about it in that way. We talk about it in terms of the geek speak. For those organizations that are mandated to do it, most of whom do, But if we made it easy, if we made it economically feasible, if we made it so that they felt like they were contributing to the national good in some way, and sort of other hats that I wear, I meet with investors who don't have a clue about national security. They don't have a clue about, complex IT systems. But what they say is, I've made a lot of money in my life. It's real estate or it's whatever they've done. And I want to contribute to the national good. And so that's the context, I think, that when we can get companies to understand that they're contributing to the national good simply by not throwing this stuff into a landfill somewhere, and it's beyond recycling. It's actually a contribution to the national good, and then I think we begin to build scale. We begin to bring prices down. We begin to fill that national supply need for rare earth elements. We do the things that we need to do to become a much more self-sustaining and truly a much more self-sustaining, because we got the life cycle part down. Then companies like Securis become a critical link in that chain as well, because you're the outward looking face to the private sector.
Yeah, perfect. And I probably should have mentioned the good work that folks over at NSA have done on the evaluated products list for shredders and degaussers. So that's certainly helpful. But maybe I wanted to switch the conversation a little bit. I've got a lot of friends who are chief information security officers, CISOs, and the defense industrial base. And I've had conversations with them, and some of the hot cybersecurity topics today are software supply chain, cloud security. That's all the new rage and what you have these folks talking about. But do you think that the defense industrial base and the government should be paying as much attention to end-of-life electronics as it is some of these new hot cybersecurity issues?
Without a doubt. Without a doubt. I believe that there are devices sitting in warehouses that have highly sensitive industrial secrets on them. I've used the term secrets, maybe that's a small s, but sure. But intellectual property, I think, so I'm going to give you another example, and it can be edited away. But my wife has a friend who does estate sales, and so occasionally she'll go help. He'll need help setting up, somebody's parent dies or a grandparent or some friend or something. There's nobody left, and they hire a company to come in and sort of run an auction or run a sale and get rid of all the stuff. So she did this a couple of weeks ago, and she comes home and she says, you're not going to believe this. This guy who died had a box, and it had, like, I think there were 27 hard drives in there. 27 hard drives in a cardboard box. And the guy who runs the estate sale said, I'm gonna, we'll sell them for $2 a piece or $5 a piece or whatever it was. And I said, go tell Duke, don't you dare. I said, you have no idea what is on those hard drives. What if you're selling somebody's pornographic library? Or worse, what if it's child pornography on there? What if you have no idea that what they ought to do is take them to a place that's going to grind them up and shred them and get rid of them. And I think that situation occurs, all over the country, probably 1,000 times a day. It's probably not pornographic libraries, but it's probably personnel banking information, social security numbers, all sorts of personal information. And it's so easy for somebody to go to a sale. I mean, these estate sales are all over, go to a high net worth area, go to an estate sale and buy a used computer and see what's on it.
Dick, you are right. So iSigma did a study and bought electronics off of eBay. More than 40% of them had either corporate or personally identifiable information on them. Rapid7, who's a cybersecurity company, they bought infusion pumps off of eBay that were in hospitals, and they were able to get the wireless configuration data from 7 hospital chains. So you're right; those things are a risk. So I'm going to ask one last question, and then maybe we'll call it a wrap. This has been awesome. Thank you, Dick, and thank you, Bill. So, Bill, not too long ago, maybe, I think in the last 2 years, it was probably going back to your time at Seagate, you started to approach Securis to help what now became your company, and I'll post the link in the show notes to this, to help the DoD solve this issue that is at the intersection of supply chain, cybersecurity, and sustainability. What made you decide to partner with Securis on this?
So just like I did a due diligence on all the various reclamation technologies, I did a similar thing on information technology asset disposal companies. And the name of Securis came up multiple times for the quality of work, the quality of the record keeping, the responsible method in which they did the work, and the fact that you were doing work for both the federal and state and local governments. And I became such a fan, and this predates you, Kurt, that I actually hosted multiple tours. Dick, I'm not sure if you're part of these, but we hosted the industrial policy people for supply chain from the Pentagon. We hosted the Defense Logistics Agency, who's responsible for the Strategic Reserve. We hosted the Department of Energy Industrial or Advanced Manufacturing Group. And it's interesting to me, every time I was on a meeting with various government executives, often that were set up by Dick, what we found was that many of the people that set the policies around the supply chain, around defense logistics, had never visited an asset disposal facility. And so I brought them out, and typically they'd say, I'll give you 30 minutes, I'll give you 45 minutes, and I'm out. A couple of times, Dan and I had to run them off the facility at the end of the day because they didn't leave, because they had so many questions. And here they are setting policy around responsible destruction and reclamation, and yet have not had an opportunity to tour such facility. Given your proximity to the Beltway, your company, it is ripe for bringing people out from various headquarter locations in the federal government to see a very responsible company do what you do, and how you do worry about the full supply chain and keeping the proper records and keeping up to speed and being a leader in the certifications required in that industry. You are always ahead of the game. And so it was easy for me to become an advocate and host those tours. And y'all did a great job of hosting the various government representatives so they could learn more about how their policies were affecting industry.
Awesome. That's it. Well, thank you, Bill. Thank you, Dick. Really appreciate having you on. Your partnership, what you're doing for sustainability, what you're doing to protect our national security interest, and looking forward to more great work on solving these problems.
Thanks,
Oh.
Kurt.
Yeah, thank you, Kurt. And I just leave you with, you should be unapologetic and ruthless in demanding of your government, my government, the best processes, the best approaches. You live it day to day. You know what works, you know what doesn't work. You know what works well, what needs to be fixed. And you should be demanding of the government solutions that actually work for the masses, not just for the people, as Bill pointed out, people that set the policy who've never actually done the work to understand what do those policies actually mean. So, be unapologetic and be ruthless.
Awesome. Well, with that, we'll end. Thank you for that advice, Dick.
Thank you.
Thanks.